right. Watch it be 2. Maybe it won't work today, but we're going to give it a go. Okay. Hopefully it's not too lagging from my computer to the board. So inverse of a relation. So the last lesson, okay, I'm going to read through this and then we're going to go through how to sketch an inverse and how to come up with, if I have an original function, what the inverse function is. Okay. But you haven't done any work with inverses before, so this is new for you guys. All right, so inverse. So the inverse of a relation is found by interchanging the x-coordinates and the y-coordinates of the ordered pairs of the relation. So if you interchange x and y, that is now going to be an inverse function. Okay? So sketching inverses are super easy because all you do is take all the original ordered pairs. So if you have a point 3, 2, guess what the inverse ordered pair is? 2, 3. It's that simple. Okay? You just flip x and y. That is now called an inverse point. Okay? So in other words, for every ordered pair x, y of a relation, there is an ordered pair yx. So flipping the ordered pair on the inverse relation. This means that the graph of a relation and its inverse are reflections of each other in the y equals x line. So that's kind of hard to visualize right now, but once we start sketching, you'll see that the y equals x line, guys, sorry, just so you guys can visualize, a y equals x line is a horizontal line that goes through the origin, right? Because 1, 1, 2, 2. So all inverse graphs, the points will be flipped over that line, right? That's what will end up happening if you flip all the ordered pairs. Which again, hard to visualize right now until you actually sketch one. But that is an important piece. Because in instructions sometimes, guys, they will ask you, sketch the graph, right? That is a reflection over the y equals x line. So if you read that sentence, that is another way to say inverse, okay? Because they're not always going to say sketch the inverse. So if they do that, perfect. That's obvious instructions. But if they say reflect the graph over the y equals x line, that is another way to say sketch the inverse. There's more notation, okay? So other notation, the inverse of a function y equals f of x may be written in the form of x equal y of f. If you see this notation, that also means inverse. That one, students, that's probably the most common notation. And this one's obvious, because can you clearly see that x and y got switched? Yeah, so this is the notation that students like, because it's very visual. They can see x and y got flipped. That just means inverse. Okay? The inverse of a function is not necessarily a function. We'll talk about what a function is because it's been probably a while since you went through that definition, but we'll finish this, then I'll go into more detail about that. So when the inverse of f is itself a function, it is denoted by, sorry, get rid of that. It is denoted by this notation here. We're so used to, guys, that little -1 in this notation is not an exponent. Okay. So if you see this notation, it also means find the inverse of the function. Okay. So there's kind of 3, I guess 4 ways that they can tell you to do inverse. One is, say, reflect over the y equals x line. Okay. This notation here, which is the most common, students like. That notation. You see this notation, that also means inverse. And the other one is when they physically say, find the inverse. Right, that's the most obvious one. Yep.
How come there's so many different ones?
Just because there's so many different ways we can denote mathematics for symbols, I know. Why not just stick with one and go with that one? But yeah, they just all are equivalent. Because do you guys agree in math there's so many different forms that are equivalent? So mathematically saying sentences, same idea. And again, this one, right, doesn't show up. This one here doesn't show up very often, okay? Because that one can only be shown if the original is a function and the inverse is a function, right? So that one, like I said, is probably the least one that pops up. And since we're talking about it, do you guys remember what a function is? It's way back in your brains, right? So what a function is, if you have a graph in front of you, okay, so if you're picturing a graph, let's see if this stirs your guys' memories. Ah, nice, exactly. And then we'll go through the definition. Yeah, so if I gave you these two graphs, one's a function, one's not. Okay, the first one is not a function. So in 10C, if you had the graph in front of you, you did what we call a vertical line test, remember? And if you touched 2 or more points, it was not a function. So by definition, for a relation to be a function, for every input, there can only be one unique output. So what that means in layman's terms, you cannot have points on top of each other. Okay? Hence, it doesn't pass the vertical line test. So this first one, not a function. The second one is a function. So when we do inverses, okay, what's going to happen to these graphs is, believe it or not, this graph right here, that is a function right now. When we do the inverse of that, which we're going to do today, right away here, when we sketch the inverse of that, guess what's going to happen to it? It's going to turn sideways. Because just think, all the points, we have to flip them. So it's going to turn sideways, which now is not a function anymore. Okay. And then guess it's going to be fun. Then we're going to have to restrict the domain so it does become a function. But that will be towards the end of the lesson. We're going to start easy peasy to begin with. Okay. All right. So first one here. Right. So we have a piecewise function. Okay. And so it's called f of x. So sketch the graph of the inverse relation. Right. So these are free marks. Because all you have to do is, I'm going to sketch 1, 2, 3, 4, 5, 6. Is there 6 key points on that graph? So we're just going to flip all those. So when I say flip, no negatives, no positives. Flip just means if a 1 is a 2, 3, I'm going to graph it now a 3, 2. That's it. Okay. So let's go through. So this negative 6, 4 point, so this one right here, negative 6, 4 is now become 4, negative 6. That's it. Right? So negative 6, 4 becomes, oops, forget a color, becomes 4, negative 6. Okay, it is writing good. And then the minus 4, 6 becomes 6, minus 4. I'm going in order and joining my line so I don't forget the order, okay? And then 0, 6 becomes 6, 0. So far all the points moved from the original. And then the next one is 2, 2. So 2, 2 is still 2, 2. What's that going to be called? Yeah, so there's an invariant point. All the other points, even though they might have toppled onto an existing point, did all the other points move so far from the original? Yes. Right, every single point has moved so far except the 2, 2 point. That's the only invariant point I have so far. And maybe ever. Okay, so now I'm at 4, 2. So 4, 2 becomes 2, 4. It moved. And then my last point is 6, 0. It becomes 0, 6. So even though it toppled onto a point that was already there, it still moved from the original. Sorry. So that, it's hard, it's nice because I have color, but it's harder with the pencil seeing it on your guys' page though probably. But that is now called an inverse graph. And I'm just going to pencil in that y equals x line because then you can see the visual that all the points did reflect over that line. So the y equals x line is 0, 0. Ooh, that is not what I want. Not that thick. I'm just going to pencil this in so you guys can see it. It's not part of the graph, but I want you guys to see 1, 1, 2, 2. So this is my y equals x line. And it goes in the other direction too. Here we go. And the reason why I'm penciling it in And you guys don't have to. If I asked you guys to sketch the inverse graph, you'd be done. You don't have to pencil the y equals x line in. The only reason why I did is so you guys can see. Do you guys see now how all the points are reflected over that line? Right? Boom.
That looks like a bow.
Right? So all of them are sorry, went to the wrong one that time. All of them are reflected over the y equals x line. Right? So it just gives you another visual. Did I plot them all properly? All right. So now we can answer some questions. So sketch the graph, check, we did that. State the domain and range of f of x and its inverse. Okay. So f of x. So domain, look at horizontal. So I'm looking now back at the original graph. So my domain of my original is from -6 to 6. That is the domain of the original. I'm going to use easy notation this time. But then I have to title it, so I don't know if it ends up being easier. So -6 to 6. And then my range. So bottom of my original graph is 0, and the top is 6. So the range of the original is 0 to 6. Both have square brackets, both numbers, if you're using the easier notation for this one, because it includes the number. It touches there on the graph. Now my inverse graph. Okay, so my domain. What's the domain of the inverse now? 0 to 6. And my range is -6 to 6. Did they just flip? I don't like them. I'm going to write it so it looks the same as the other one. Did it make sense, guys, that they should have flopped like that?
Is it always going to be that?
Yeah, always. Which should make sense, because what does x deal with? X deals with domain. Y deals with range. So the nice thing is, if you guys have an original function or graph in front of you, you don't need the inverse. Everything's opposite. So the domain of the original will become the range of the inverse. The range of the original will become the domain of the inverse. The x-intercepts or intercepts of the original will become the y-intercept of the inverse. The y-intercept of the original will become the x-intercept of the inverse. Everything's just flopped. So a lot of the questions, guys, if you have the original information, you don't need to sketch inverse or do inverse at all. You can just use all the original information and apply it accordingly, right? Because a lot of times the question will be, given this function, what is the domain of the inverse? I would not get the inverse, right? That's lots of work. I would just get the opposite in the original, right? So again, if I want the range of the inverse, I would just take my original function and find the domain, right? But again, the other option is do all the work, find the inverse, and get it that way, but way more room for error. All right, and again, that will always be the case. Okay, is everything is just flipped, because that's what we're doing. We're changing x and y. So all the characteristics will all flip, okay, because these are characteristics. So determine whether f of x and its inverse are functions. So f of x, was that one a function? Okay, so look at the black line. Is that a function? Is there any 2 points on top of each other? No, so that original is a function. So f of x. So f of x is a function. Is the inverse a function? No, right? The inverse, boom, you can see on the far right-hand side there, right? At 4, there's definitely 2 points at 4, right? There's 2 points at 6. There's 2 points at 5, right on top of each other. So the inverse is not a function. Make that bigger. So if you didn't sketch it like we did, okay, we know that we can do a vertical line test on the original to see if the original is a function. Guess what we can do to the original to see if the inverse is a function? A horizontal line test, if you didn't want to sketch it. Right, if the graph was just there and I asked you is the inverse a function, yeah, you could sketch the whole thing, but I wouldn't. I just take the original, do a horizontal line test, and if I hit more than 2 points, okay, or more than 1 point, it's not a function. Okay, it's just something to think about, right? Because again, if I don't have to sketch the whole thing, I don't want to. All right, so this is the one that's interesting. How many invariant points are there when I sketch this? 1, okay? A lot of times people say 3, okay? Because did 2 other points end up moving but go on existing points on the original? Yes, but they moved, okay? So invariant points are ones that don't move. So the only invariant points are going to be on the intersection of the y equals x line, right? So the y, if you sketch the y equals x line, how many times it touches, the graph, the original graph touches it, will be how many invariant points. So there's only one time the original and the inverse, obviously, right, touch there. There's only one invariant point. So make sure if it moved, it's not invariant. So 1 at, and here it's a nice point, so I'm going to put it in there, at 2, 2. So there's one invariant point at 2, 2. A lot of times the invariant points, guys, you could approximate what they are, but they're not always going to be nice integer values, okay, like this one was. All right, so you guys go ahead, do the worksheet, and I'll just quietly do it behind you. Make sure you got her down. Normal. Still some hiccups with this. So you guys are going to be way ahead of me now. catching up to you guys quick. How many invariant points did you guys say?
1.
There's actually,
Is
draw the y equals x line. How many points, how many times do you touch? So I'd agree there's one nice one, but is there another one? Exactly. So that's why here it just says how many, right? Because if you draw the line, right, it's going to touch twice, right? Not just once, right? Because it crosses here as well, right? Even though it's not nice, it's still part of it. So I always just draw a quick little, right? And I purposely didn't this time just so you guys see if you guys came up with it on your own. But yeah. So it does, it would hit the original twice, hence it does intersect twice. So one nice one, but one not so nice one. So there is 2 invariant points. Right. So sketching, students love these questions because they're kind of like a, yay, here's a Merry Christmas present on a quiz if all I'm asking you to do is sketch an inverse. Because it's simple. You just flip your points, replot it, and then we know that everything to do with the characteristics are like flip as well. So domain goes to range, range goes to domain, and x-intercepts become y-intercepts, y-intercepts become x-intercepts. Okay, all that stuff happens. Okay. All right, so the other thing though, I'm not going to do that. I'm going to go back to example 2 after. I want to do the next algebraic thing, and then I'll go back to restricting a domain. Okay. I'm going to flip around a little bit. Okay. So I'm going to do A and B here because it's very algebraic. Then I'm going to go do the graph. Then I'm going to come back to C. I know I'm all over the place, but I feel like that will help with understanding if I do this first. All right. So here it says algebraically determine the equation of the inverse of a function, right? So each function. So I'm going to do A and B with you guys right away. So with this one, y equals 3 over 4x minus 5. So technically, algebraically, y should become what? What happened above? Y became x, and x became y. It still happens here. So to get your new inverse function, that y you're going to change to a x. That x is going to become a y. And then you're going to use your algebra skills to rearrange the equation. Because you can't leave it as an x equal equation. Even though, I'm going to do that, I'm going to write it down. X equals 3 over 4y minus 5. Technically, you could be, Ms. Calvert, that's the inverse function. I'd be like, yep, it is. But Alberta Ed will not let you leave it like that and get full marks. Okay. They expect you to leave it so you could type it into your calculator and see both graphs. Because right now, can you type in an x equals equation into your calculator? No. So you're just using your algebra skills, all these skills you have. Okay. So you do have to do a little bit of work. You can't leave it like that, right? So this one, I'm going to move it in 3 steps, okay, is how I'm going to move everything. So the first thing I'm going to do is get rid of, I have to do this first. It makes the most sense to do this first, is I'm going to move the minus 5. So I'm trying to get y by itself. So what do we do with the minus 5? Exactly. So we add 5 to both sides. Sorry, I don't know why this keeps doing that. Do that. There we go. Okay, I think I figured out how to fix that now. So we add 5. So add 5 to both sides. And you don't have to show this step up here. I don't know you guys well enough yet to know where you're at. So I'm going to show all my work. You obviously wouldn't have to write that down. Okay, so now I have a x plus 5 equals 3 over 4 y. Now at this stage here, Okay, I know normally because it's 3 over 4 times y, normally we divide whatever's on the y. But when it's a fraction like that, I prefer you guys do it in 2 steps. Right? It's just so it doesn't get nasty. Because I shouldn't say I. It will never be written like this on a diploma where, oh my goodness gracious, please don't do this. Because technically, is that right? It is. But you'll never ever see something like that. Okay? So I would hope that you guys would do, and it's, to me, it's compact, it's nicer. I would hope that you guys, what's opposite of division? Multiplication, so I'd multiply that over. Right? So then I would go either 4x plus 20, or you could leave it as 4 bracket x plus 5. Both are acceptable. Okay, because they're equivalent. Do you guys agree? 4 times x plus 5 or 4x plus 20, same thing. They're not going to simplify, so both would be acceptable. I don't care which one you write. So then now I still have 3y, and then now I can divide by 3. Okay. So when you have a fraction, do it in 2 steps. Or think about it this way. Divide by 3 over 4 is the same thing as times by 4 over 3. Which is what I'm going to get now. Because if I divide by 3, that is the same thing as a 4/3 on the outside. And then, so divide both sides by 3. So we have 4. And like I said, if you rather leave that as a 4x plus 20, that's fine. I like leaving it in factored form, but all equivalent. Right, so with the next one, interchange your, I was charging it, right, Jane? Yeah. Oh yeah, it's still good. Just a minute, where did it go? No problem. No, it's all good. All right, so first step. So does it make sense just before I go to the next one? The original, this little guy was linear, right? Just because these graphs you should be able to kind of visualize. If I take a linear and I do the inverse, does it still make sense I have a linear? Yeah, a linear and a linear, right? You're going to get a linear. So with this one, interchange. So I have x equals 4 bracket. So this one's going to have a little bit more serious algebra, right? More steps to do. Duh. If you don't double exit like I just did, I'm fixing it. Give me a second. I talk sometimes and my brain doesn't correlate with what I want it to do. Now we're good. So y became x, x became y. You're still now trying to isolate for y. Okay, so we have some steps. So the first thing you need to do, or I would do, is do the constant. So that minus 8, we're going to get rid of it by adding 8. That would be our first step. So then we have x plus 8 equals 4 times y minus 1. Please, guys, don't expand this, right? Because we're so used to seeing a degree 2 binomial and want to expand it. That will create an equation that you can't isolate for y. Because if you expand that, you're going to end up getting a y squared and a y. Would you agree? If you expand it inside, do not expand that. Otherwise, you can't do the algebra. Okay? Leaving it as the degree 2 on it, right? At one point in time, we're going to square root to get rid of it. That's what we need to do. But I want to isolate that binomial first. So the next thing I would do is get rid of that 4. So right now it's 4 times. So I have to divide both sides by 4. So divide both sides by 4. And this doesn't divide nice, so just leave it as a fraction. If it was like a 4x plus 8, then the 4 would divide up. But since it doesn't divide into both, just leave it as a fraction. So this would be x plus 8 all over 4 equals y minus 1 squared. You guys have seen a square in algebra a million times, right? Pythagorean theorem, all your trig stuff in 20-1. How do you get rid of a square in algebra? What do you do to both sides? You square root both sides. This is the piece that way too many students forget, not the square root part. Students remember that quite well. What they do forget is anytime you square root something in algebra on both sides, what goes in front? Does anybody remember? Nobody remembers? Okay, let's remind you guys about something. All right, so if I go x squared, don't write this down. If I go x squared equals 25, just logically, what's the answer to this? 5. Is there any other answer? Negative 5.
Oh yeah, I think those were
There's two answers, okay? Because minus 5 squared is 25. Positive 5 squared is 25. So in algebra, especially in 20-1, remember all that trig stuff? If you forgot your plus or minus, you didn't actually get the right answer. So here, anytime you square root both sides, there always should be a plus or minus. It's just in 20-1, you guys had to figure out, did I need both answers? Depending on what the question was, okay? So here, you need both answers, and I'll show you why in a minute. So you do need that plus or minus there, okay? So when you square root, I'll put it on the next line, just to not get too combobulated with stuff here. So now I'm at plus or minus x plus 8 all over 4 equals y minus 1. And I'm almost done, right? So now I can add 1 to both sides. Not majority, but more than 30% of a class normally will forget the plus or minus. But I'm going to hopefully tell you the reason why you need it there, so you understand that you shouldn't forget it, because the graph isn't complete if you forget it. Which again, makes no sense yet, but I'm going to show you on the calculator. So let's finish this. So this would be plus or minus square root x plus 8 all over 4 plus 1 equals y. This I would give you full marks for, right, on a quiz, okay? On a diploma, to me, they would expect you to do one more simplifying step. Okay, they would expect you, which I get, because it is a simplifying step that you guys should know how to do. When you're dealing with radicals, remember, if you have a fraction, you can break it up like that. That's equivalent to this. And the only reason why they would do this is because the bottom is a perfect square. If that was a 3, we would be having this conversation. Okay. But since it's a 4, radicals, like I said, when they're fractions, as the radicand, you can break it up into separate pieces. That it is equivalent. So then you would have plus or minus x plus 8, because that's an expression that won't simplify, all over 2 plus 1. So that was quite a bit of work, and again, I showed every single step. Some of those steps you can do in a couple steps in one. Now, I know I'm showing you guys everything just because I want you guys to understand the whys and hows of everything. So I want to show you the graph. So y equals 4, x minus 1, right, squared. Now, if you forgot, okay, if you forgot that plus or minus, sorry, minus 8. If you forgot that plus or minus, then you would say the inverse would have been, whoopsie, go to the next line, Calvert, there you go. So square root x plus 8 divided by, oh, I'm going to do it this way so you guys can see the order of operations. So square root x plus 8 all over, since I simplified, 2. plus 1. Did I type everything in right? Yes, I did. So notice, and the thing is, guys, for you, because the inverse isn't a function, your calculator only graphs functions. So for you to get this graph, that's where the plus or minus comes from. So if you forgot to put that plus or minus, you're saying that's the inverse. Am I missing a piece? When you do an inverse of a quadratic, which we haven't sketched it yet, but we know that a quadratic looks like this, should I still have both pieces when I do inverse? I should. So I got one piece. Okay, I got the positive piece. I need the negative piece. And when it's not a function, you have to put it in as two separate pieces. It won't do a plus minus. The calculator doesn't have that capability. So then you would have went negative square root x plus 8 all over 2 plus 1. Now you have the inverse, right? So the plus or minus, right, is technically wrong if you don't put it, because you've now restricted, right, the inverse to only one of the branches, and I had both branches to begin with. You guys agree? First one, have both branches. So if I have both branches on the original, I need both branches because I'm not asking you to restrict anything. So I need both branches, so that plus or minus does that. Okay. And the algebra does that too, but so many students forget the plus minus in algebra when they square root both sides. Right. Right, almost done. Okay, so now let's go back up. Because like I said, I want to leave this one for right now. I want to now do the restrictions on the graph. So I'm quietly going to, so you guys graph using your graphing calculator or paper pencil. Go ahead and do the graph. Sorry, it got flipped around here. Oh, goodness gracious. Sorry, guys. So go ahead and graph, was it x plus 2 all squared? Yeah. So here, graph f of x, you're going to graph x plus 2 all squared on the graph. Okay. Totally use your calculator if you want, right? Go y equals x plus 2 all squared, get those points on there. And then just interchange, just like we sketched the first two. There should be at least 1, 2, 3, 4, 5 points that you're going to graph on here of the original. And then switch all the points and sketch the inverse. So that's what I want you guys to do, is graph the original and then take the points that you used to graph the original, flip them all, and sketch the inverse. So do not algebraically find the inverse. That's not what I want you guys to do. Just take the points, those points that you have, and sketch it like we did the first graph. Everybody has the graphs? All right, so did anybody not use their calculator and do the graph with transformations? Nobody did, everybody used not that it mattered, right? But we do know that this is just a quadratic graph that moved left, what, 2. So I plotted that and then I just picked a couple points around. But again, sometimes the calculator's faster. So then all I did is I flipped the points. I went -2, 0, 0, -2, right? Boom, boom, boom. So inverse, not a function, right? You could have did a horizontal line test on the original to also answer that. So inverse is not a function. So it says, what is the domain of f of x? So f of x is our original, which is the orange graph, right? That one goes from -infinity to +infinity because it's just saying the domain of the original. So right now, the original has no restrictions on x. For every input, right, there is a output. So my domain of f of x, right, is x such that x is an element of all reals, right, or -infinity to +infinity, right? That's the two ways we can write the domain of the original. Since it's titled, I don't have to title that. It says what is domain, I'm filling in that space. So here, this now, guys, is what Alberta Ed considers a standards of excellence question, is this next question, okay? Not that it's that hard, it's just wrapping your brain around what it's asking. And once I hopefully explain it, it's going to be good. But please talk to me if it's not. So here it's saying, how can the domain of f of x, the one we just wrote, okay, how can the domain of the original be restricted so that the inverse of f of x is a function, okay? So with this original graph, I need you guys to be okay that this branch right here correlates with this branch. Do you guys agree? Do you guys agree that those two branches correlate to each other? So if all I did was sketch that part of the graph of the original, would the inverse be a function? Right, if I just said, you know what? If I added on to this, where x, you guys did this in 20-1 and 30-1 a little bit, or not 30-1, 20-1 a little bit, where x was greater than or equal to -2. If I said graph this whole graph, but only the piece, remember all that piecewise function stuff you guys did? Graph this function, but only where x was greater than or equal to -2. Would you guys have to erase this? Would you guys have to do that if I put that restriction on the original? So if I did that, would you now have to erase this? Would you have to do that? If I put that restriction and said only graph this, but only the values where x was greater than or equal to -2, this would now be what the graph looked like. Is the inverse now a function? Yes. That would be a restriction that you could apply. There's infinitely many answers, guys. Okay, so I'm going to put all that stuff back. What if I did this? What if I said, change the question to graph that function, but only where x was less than or equal to -2? That would also work. Would it be the other side now? So if I said this, but put that restriction, normally I'd say the where. I write that word in between. Where x is only values less than or equal to -2 instead of the domain that it is, then you guys would be looking at is that what you guys would be graphing now? Is that now a function? Yep. You guys see where I'm going with this? Is there infinitely many answers you can get? You don't know what I'm saying? Oh, so remember you can't have points on top of each other. So for every input, there can only be one output. So when I put this back on here, there we go. So this right now is not a function because is there points on top of each other? So because there's points on top of each other, it's not considered a function. So a function is for every unique input, there can only be one output. Not along the x-axis, it's just like vertically. Like it could be anywhere on here. Like if I drew again, oh, thank you. Right, if I drew this graph, oopsie, whoa. Oh goodness gracious. Da, da, da. Right, if I drew that graph, that's not a function. Is there points on the orange graph? There's points on top of each other, so that's not a function. Right, so what we're doing is if I give you original graph, right, so the original graph was this right here, okay, which, oh, it's going to be one of those days, okay. Calibrate. Be magic. Calibrate. Oh, Lord, it looks normal on me. There we go. So the original graph is the orange graph. Is it a function? Yes, right? But when we did all the inverse points, is the inverse a function? No. So we have to... So if you have points on top of each other, yes. If you have, yes, so if you have points on top of each other, that determines whether it's a function or not. So if there is points on top of each other, not a function. So we're restricting the original graph. So if we graphed it, right, the original with the restriction, then this would be a function. So I'm saying is if in the original I asked you to graph this, right, that restriction by putting that on there doesn't make you graph the whole thing. It only makes you graph where x is greater than or equal to -2, which is this branch. So if I'm only graphing this branch on the original, then I'm only graphing this branch on the inverse. That's how I can restrict the original function. And again, could I do the other side? Yes. I like using the vertex points, right? And the vertex point means the point that basically cuts the graph in half. I like using that point. But technically, guys, I don't want to get too crazy with you, but I need you guys to see that there's infinitely many answers. What if I said this, where x is greater than or equal to 0? Would that also be an answer that's possible? Yeah, because greater than or equal to 2, greater than or equal to 0 would be this piece, right? Which also would be this piece, right? That would also. So technically, on your quiz, which is in a couple days, if this was a written question, could all of you give me a different answer? Every single one of you could give me a different answer, and you all would be correct, okay? But it can't be anything, right? It can't be like whatever you want. What if you wrote this on your quiz? X is greater than or where x is greater than or equal to -4. Would that one work? No, that one would not work. Because greater than or equal to -4 means this, right? So then on the other graph, it would be, oh, let's use a different color. See how that would be a problem? Please calibrate. Anyway, it would be this piece right here, right? And do I still have points on top of each other? Yes. Okay. So you can't write anything. It still has to restrict the original. The only time I have students mess this up is they restrict the inverse. They restrict the second graph. Okay, you don't restrict the second graph. It clearly says in the original, because the second graph doesn't exist until you graph the first one, right? So it says, how can the domain of f, which is the original, be restricted? So what kind of where statement could you make on the original to make the inverse a function, right, is all. Right, so with that one, what I want you guys to do is do that last algebraic one, and then I'll quietly work behind you. So the last so a couple choices, so I'll write them in here. So you could restrict it where x is greater than or equal to -2, or x is less than or equal to -2. There's infinitely many answers. So on the diploma, they'll just get creative with it, right? So since there is infinitely many answers, they might, because are you guys noticing it's revolving around the horizontal translation, the number that I'm using? It doesn't have to, but the easy number that I'm using is that H value. It revolves around that, is the most common answer they'll use. So they'll use a variable there. They might change the 2 to a Z. So then these statements are written in terms of Z instead of a 2 or a -2. All right. So with that, please finish this little guy. Be careful with this one because there's a little twist, but I'm not going to say much more than that. You guys try it, see if you catch the twist. And then after that, don't do the diploma questions first. Do some of the textbook questions. Then go back and do those diploma questions that some of you skipped on yesterday's lesson because we're going to go through those ones first. Then try these babies. Okay? But by the end of class tomorrow, we'll go through all the diploma questions and kind of check them to make sure that you got the right answer and then talk about the ones that you might not have got. Okay? But do this first. Again, f of x just means what? Y. F of x is just notation for y. Okay? So that now is going to just change to a